So yes, we use that ratio of 2/5 the length. We squared it for the surface area, cubed for the volume. Where does the 1200 volume go? Bottom, because from the larger figure, we'll cross multiply and divide to get, what's that? 76.8 inches cubed. What do you think? Need more practice? Well, fortunately for you, you're about to get more practice. Before we do the quiz, though, does anybody have any questions off that page of homework we got? The tough part now, the stuff I'm going to give you, by the way, is going to be pretty straightforward on the quiz. You'll have a picture, find the volume, find the area, whatever. On here, the tricky part was trying to figure out whether it was a volume or an area. Like for number 8 on that worksheet, the wastewater, a pipe of sewage treatment plant, is 75 millimeters in diameter. Discharges 2,000 liters of water in a given period of time. If the pipe needs to discharge, so they're going to get a bigger pipe, so it discharges 3,000 liters of water, what's the diameter have to be? Is this an area problem or a volume problem? It looks like a volume problem because we're going from 2,000 liters to 3,000 liters. But we're assuming that the flow rate of the water out of the pipe is the same. So if the water is coming out of there at 2.5 meters per second in this pipe, it's coming out at the same speed of this pipe. To be a volume problem, it has to change all 3 dimensions. By changing the diameter, we're only changing 2 dimensions. We're only changing the area. It's called the cross-sectional area of the pipe. So it looks like a volume problem. You want to change the volume or the capacity of water coming out of it. But you can't assume that we're changing the velocity of the water. If, let's say we're going to double the diameter of the pipe, that would make the surface area, or the area, go up by 2 squared or 4. But it doesn't make the volume change by that much because we'd have to also double that depth, that length. And in this case, that depth is the speed of the water coming out of the pipe. And we don't have the control over that. So this is actually an area problem. So we're trying to do a 2 to 3 ratio here, going from 2,000 up to 3,000. I'm just going to reduce it to 2 to 3. We're going to square that to get a 4 to 9 ratio. And the 75 millimeters goes with the smaller one, the 4. So 9 times 75 divided by 4. Make sense? That gives you the diameter of the new pipe. That's I specifically wanted to bring up that example because of that. Because it very, very, very much looks like a volume problem. But it isn't. But it is just an area. Because that's all you're really altering by changing that diameter is the cross-sectional area. Make sense? On the quiz, I'll be very straightforward about it with just, here's a shape, find the area. It appears as though the quiz is going to take us to the end of the period here. In the packet that you have that has the measurements calculations on front, the one that's printed, not the one that's copied from the textbook, has the adding and subtracting measurements. Not that one. The one on the bottom of your pile there. Here's
packet number 1 then?
That one, yep. That's the one right there. If you just want to take a look at like the next 5 or 6 problems and see what you can figure out, we'll talk about those more on Monday. Yep, that's the one. So when you're done with the quiz, I'll let you out of here for the day.